Hey class, Miss Anderson here. Let's review all of what we learned in Unit 4. So just a reminder, I have the sum and difference of cubes formulas up here for you. Those will be given to you on your Unit 4 exam as well. You will need to know how to use them and when to properly apply those formulas. But this unit was mostly about polynomials. So in general, polynomials we're going to be working with, remember they have to have whole number exponents and then real coefficients. I wanted to give some examples of some non-polynomials since we're going to be working with a lot of polynomials. You'll see plenty of examples of what they do look like, but here's what they don't look like. Like a y equals 2 to the x power can't have an x in the exponent. It's a function, it's not a polynomial. X to the -3 power, rational function, not a polynomial. Same with if you have an x in the denominator of a fraction. So those are just some classic examples of functions that are not considered polynomials. So we started with polynomial operations like adding, subtracting, and multiplying polynomials. So let's just review that. When adding or subtracting a polynomial, we're going to be combining our like terms. We're just finding the total amount of the like variables terms or the difference between the like variable terms. So in our first example, I'm going to start with my 2x cubed because I want to put it in standard form. So that one has my highest exponent and there are no other x cubed terms. And then I have an x squared, which is a 1x squared, plus a 3x squared, so a total of 4x squareds altogether. And then I have a minus 5. And so that I just added my like terms. I didn't change the exponents at all because when we're adding, we're just finding the total number of x squared terms between the two polynomials. Subtracting works similar. Except for that with subtracting, when we're subtracting a trinomial like this, you have to remember to subtract each term, not just the first term. So you would do minus 4x squared, and then minus a -8x would make that plus 8x, and then minus 6 would make that plus 6. And so I like to think of it as just adding the opposites. And so I changed that to plus, and then we can go ahead and put this all together. And we're going to be adding these polynomials. So now we're finding the total. The x squared terms are my highest exponent, so I'll start with that. I have 1x squared and a -4x squared, so I have a total of -3x squared terms. And then I have a -4x and a +8x, which is 4x, and then plus 6, which is 12. And then this is listed in standard form, highest exponent down to constant. -3 would be my leading coefficient. It'd be a degree of 2, quadratic, trinomial. So remember to review all of those things too. When multiplying, you can FOIL. So multiply x by everything, multiply 3 by everything, write down 6 terms, combine like terms. I do like to organize these ones with the box because it helps to keep it organized. We don't lose any of our terms and you're less likely to make a mistake. So we put x plus 3, 2x squared minus 4x plus 5, and then we're multiplying, which is the same thing we were doing when we distribute. Like x times 2x squared is my top row is distributing that x. So when we multiply x times 2x squared, we get 2x cubed. Multiply the coefficients, add the exponents. X times -4 is -4x squared. 5 times x, 5x. Now distribute the 3 to everything. So 3 times 2x squared would be 6x squared. 3 times -4 is -12x. 3 times 5 is 15. And then we can combine our like terms, which typically lie on our diagonals. We have one 2x cubed term. We have 2x squared terms, so a total of positive 2x squareds between the two. 2x terms, which is a total of -7 x's, and then a 15. So that one's a cubic polynomial with a leading coefficient of 2. As a reminder, when we cube a polynomial or cube something, it means to multiply it by itself 3 times. And so that's what we have to do if we want to cube a polynomial. We have to take x plus minus 2 times x minus 2 times another x minus 2. And to do this, you have to start by just first multiplying out the first two. And so 2 by 2, I would just FOIL that. X times x is x squared. X times negative 2 is negative 2x. Then take negative 2 times the x, get negative 2x again. Negative 2 times negative 2 is positive 4. And then I would combine like terms before I multiplied by the last one. So I'd get minus 4x in the middle plus 4. Now I'm going to take that times my x minus 2. And since I have quite a few terms here, I am going to use the box to organize the work this time, just so I don't lose track of my terms. So I made a 2 by 3 box, and I put the binomial on the left and the trinomial along the top, and then rows by columns. X times x squared is x cubed. Negative 4 times x is negative 4x squared. 4 times x is 4x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is 8x. Negative 2 times 4 is negative 8. And then you'll see have those like terms in the diagonal spots again. So we have x cubed, a total of negative 6x squareds this time, a total of 12 x's, and then negative 8. So once we're done multiplying, we're using addition to combine our like terms to find the total between our four terms. So we have a cubic polynomial again with a leading coefficient of 1. After we did polynomial operations, we expanded our factoring techniques. And so the first one was similar to how we factored with quadratics back in Unit 3. So we have a quartic polynomial this time, a quartic trinomial. Our a value is equal to 1. So that means you don't need the box to factor this, but you could use it if you'd like to organize it that way. But if you're going to use the box, you would start the same way that you did with a quadratic. You would do x to the fourth and 15 here, so the first and last term. And then a times c, so 1 times 15 is 15, and then it has to multiply to 8. So numbers that multiply to 15 and add to 8 would be 3 times 5. Those go in my diagonals. 3, and it's going to be x squared, and then 5x squared because those make 8x squared. And then figuring out the outside, these two have an x squared in common. X squared times x squared is x to the fourth. X squared times 3, and then x squared times 5. So you'll notice that your factors were what you got when you did this step. And since a is equal to 1, that will be the case, in which case you can jump straight to this factors of two binomials instead of using the box. But using the box is a great way to organize the work. So do whatever you're most comfortable with. This one is perfect cubes. 27 is 3 cubed and 8 is 2 cubed. So being practiced enough with these that you recognize that and then being able to rewrite it, 27x cubed would be the same thing as 3x cubed. 8 would be the same thing as 2 cubed. So now I have an a cubed minus b cubed. So we would need the formula, which is going to go a minus b, then a squared plus ab plus b squared, where a in this case would be 3x and b would be 2. So plugging into that to factor this difference of perfect cubes, a minus b would be 3x minus 2. And then a squared, you would have to take 3x and square it. A times b would be 3x times 2. And then b squared would be 2 squared. And then reducing that, we would do 3x minus 2, 3x squared. Remember, that's 3x times 3x, so we get 9x squared. And then 3x times 2 would be 6x, and 2 squared is 4. So we got that. And then that doesn't factor any further. So when we factor difference of perfect cubes, we just use the formula, and then that's our answer. So our trinomial at the end doesn't factor any further. Then we did factoring and solving, so expanding those factoring techniques and then solving similar to what we did in Unit 3. So I actually picked the same problem, the same factoring problem, 27x cubed minus 8. Notice that this one is now equal to 0. So now I have an equation and I'm asking you to solve it, where up here I just had an expression without an equal sign, and I asked you to factor it. So that's the difference here. This one is an expression. There is no equal, and I'm just asking you to write the expression in a different form, this standard to factored form. Now I'm asking you to write it in factored form and then solve it because it's equal to 0. So I'm looking for the 3 values for x that would make this equal to 0. So I can start by factoring it. So you would use your formula that's given here, 3x minus 2, and then 9x squared plus 6x plus 4. So it's the same one I just factored. And then that's equal to 0. Then you would set each factor equal to 0, and then you would solve them individually. The binomial is a linear factor, so you can just solve it like you would a typical equation. So add 2, divide by 3, using your inverse operations, single x, so x equals 2/3. In our quadratic trinomial, since it's not factorable, that means that you have to use the quadratic formula to solve this one. So just a reminder, quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. It was really hard for me not to sing that, but I held off for you. In this one, a is going to be 9, b is going to be 6, and c is going to be 4. So we got x equals negative b, so negative 6 plus or minus the square root, be 6 squared minus 4 times 9 times 4 all over 2 times 9. I'm going to figure out the discriminant here quick first, which is the b squared minus 4ac part. So that'd be 36 minus, let's see, what's the best way to do this? 4 and 4 is 16. 16 times 9, 16 times 10 would be 160. Take away 116 would be 150, no, 144. I should probably double check that. Do I have a calculator open? Of course I don't. Oh yeah, maybe I do. Okay, so let me just check my math because it's late and I want to make sure that I am right here. 144, okay. And then can I take that answer and I'll do 36 minus 144, so it'd be negative 108 all over 18. Okay, so 108 is not a perfect square, but it can be broken up. Let's see, we can divide it by 2. So we could do 2 and 54, and 54 is 2 and 27. And 27 is 9 and 3, and 9 is 3 and 3. So I have all my factors here down to prime factorization. So I have a pair of 2's that can come out and a pair of 3's that can come out. And it's negative, so our answer is going to be imaginary. So I got 6 plus or minus. I'm going to have 2 times the 3, which is going to give me 6i. And then square root, I still have 1 3 left in there, so square root of 3, which means that I had 2 perfect squares in there. I bet if I did 4 times 9 times 3, I would get 108. So I'm doing square root of 4 times 9 times 3, and the square root of 4 is 2, the square root of 9 is 3, and then you still have a square root of 3 that is irrational, so you leave it in there. That's where I get 6 square roots of 3. And since it was negative, though, it's going to be imaginary. So I add in that I. And then it was all over 18. And then it looks like you'd be able to factor out a 6 here because all of your coefficients are divisible by 6. So if I factored out a 6 from the top, it would look like this. And I factored out a 6 from the bottom, which means like if I multiplied this in by 6, I would get this answer. So because I can factor out a 6 from both, 6 divided by 6 is 1. So my final answer for that piece would be x equals negative 1 plus or minus I square roots of 3 over 3. So this cubic equation had 1 real solution and then 2 imaginary solutions for this one. So 3 total solutions. So let me zoom out so you can pause that if you need to quick to write that down. That was a problem. Quite the process. Okay, how about this one? So we're solving again. I have an equals to 0, so I have an equation. So I'm looking for the value of x that makes this equation equal 0. Notice that I have 4 terms, which is going to be factored by grouping. So you can either group the first 2 terms and take out the greatest common factor of each group, and then you will have a group that you can factor out. Or we can use the box to factor this as well. We're going to do 4 terms. I'm recording a video, honey. 3x squared minus 8x minus 12. Mia, share, please. Okay, so I just put the terms in order in the box, and so it's the same as grouping these 2 terms and grouping these 2 terms, but this is your first row and this is your second row. Then you're looking for the greatest common factor from this row. So both of those have an x squared in common. And then x squared times 2x gives me the 2x cubed. And then x squared times 3 gives me the 3x squared. And then 2x times negative 4 gives me the negative 8x. Negative 4 times 3 is negative 12. Either go get back in the bathtub or go get your towel, please. And then we have 2x plus 3 as factors, and then x squared minus 4 equals 0. And then we can solve from here. Notice you could factor this one more, 2x plus 2 and x minus 2, since it's difference of perfect squares. But you could just take both factors, so 2x plus 3 equals 0, x squared minus 4 equals 0, and then solve them for x. So this one, I would have to subtract the 3 and then divide by 2, and I get x equals negative 3 halves. On this side, I would have to add 4 to both sides, and I get x squared equals 4. Then I would square root, and I get both positive or negative 2, since 2 squared is 4 and negative 2 squared is 4. So I get 3 answers, and they're all real answers this time. So I had 3 possibilities for x that would make this equation to 0, and they are negative 3 halves and positive and negative 2. Notice if you would have factored more, you would have got the same answers from those 2 factors as I did from the original. So when I want it factored all the way, I would want to see this step. But if you're solving, you can jump from here to here without that extra step in between. So we did a lot of different polynomial factoring and solving. So I tried to do an overview of kind of all of them here, but definitely do your review. And then the last thing we did in Unit 4 was polynomial division. We did 2 ways, long division and synthetic division. So to do long division, we set it up like this, 6x squared plus 7x minus 20. And then we do divided by 2x plus 5. And then we have to see like how many times 2x fits into 6x squared, or what do we have to multiply up here by 2x to make 6x squared? And that would be a 3x. And then we go ahead and we multiply this through, but we have to multiply it to both terms, and then we put that here. So we do 3x times 2x is 6x squared, and then 3x times 5 is 15x, positive 15x. So I put plus 15x. And now we're going to subtract, and that gets rid of our first term. And then we have 7 minus 15 would be negative 8x, and then we bring down the negative 20. And then we are going to see what do we have to multiply the 2x by again to make negative 8x, and that would be negative 4. And then we take that negative 4 and we multiply it to both here, and we're going to put that here. So negative 4 times 2x would be negative 8x, and then negative 4 times 5 is negative 20. And then we're going to be subtracting, which really is adding the opposites, which make this come out to 0. So there is no remainder. And so then the top here is our answer. So this equals 3x minus 4. And then remember, since we got a remainder of 0, that means that these were factors of each other. So that means if you took 2x plus 5, which you multiplied or divided by, and you multiplied it by 3x minus 4, you would get back to 6x squared plus 7x minus 20, because division is the reverse of multiplication. And if you divide and you get a remainder of 0, it means it was a factor of the original problem. And then synthetic division, which I liked much better. And we also did synthetic substitution. So there is a little bit of difference between the two, and I'll try to be clear here. So synthetic division and substitution are done the same way. It's the drop mama. So we're going to drop mama. So we got to line up our coefficients. We have an x to the fourth minus 2x cubed. We have 0x squared, so we have to put a 0 in for that placeholder, plus a 3x plus a 1. And then we're dividing by x minus 3. So first you're going to list your coefficients in order from highest exponent to lowest. So it's a 1x to the fourth, negative 2. We had 0x squared, 3, and then 1. And then we are going to solve this factor for x. So x would equal 3. So that's what we're going to plug in. X equals 3. And then we drop it down, and we get to do drop mama. And mama stands for multiply, add, multiply, add. I feel like my 1 got erased there somewhere. So 1, negative 2, 0, 3, 1. Those come from here. 1, negative 2, 0, 3, 1. So make sure I have the right ones. Then drop it down, multiply, add, multiply, add. So we're multiplying this number, and then we put the product here, and then you add this way. And then that process repeats over and over. So 3 times 1 is 3. Then negative 2 plus 3 is 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus 3 is 12. 3 times 12 is 36. 1 plus 36 is 37. Now, if I would have said, what is the function here? If I said this f of x is equal to, this function, and then I asked you to find f of 3, you would tell me f of 3 equals 37. 37 is when you do synthetic substitution. 37 is when you plug in 3 into your function. 37 is your answer. So that's synthetic substitution. When we're doing synthetic division, these are the coefficients of our divided polynomial. So we did an x to the fourth divided by an x, which means we would have an x cubed as an answer. And so we would have 1x cubed, then it would be x squared, then it would be x. This would be your constant term, and then this would be your remainder. So you'd write your answer as 1x cubed plus 1x squared plus 3x, because they're all positive, plus 12, plus a positive 37, and then you write your remainder over x minus 3, what you divided by. So this polynomial divided by this polynomial equals this. And that's how you can use synthetic division. And then if you just wanted synthetic substitution, that's where you plug in 3 for the function, and the last number you get is your answer. All right, thanks for watching. I hope this was helpful.